welcome to my class. Good evening. Sorry, good afternoon. This is a chemistry class chapter 2 and state of matter part 3, last part. I'll try to finish this chapter today. Okay, look at this picture here. Here's happening. What happening? Are you watching this screen? What is happening here? This is a cube of ice. What's happening? This ice.
It's melting.
This ice is melting. Here. And look, another two pictures is here. The reaction. Look, this reaction between zinc react with here. Zinc react with acid. Here sulfur burn in air, and rusting of iron occur. We know the rusting of iron. If you put iron in outside, after some days you look the rust formation occur because there is a reaction occur, chemical reaction occur in air with water vapor and oxygen and form new substance. This is called rusting. The sulfur burns in air, zinc react with acid. Okay. Here two things happening here. When here these things, this melting of ice, look this not air, like water. The water is becoming ice. Here no new substance is formed. Here is the water is H2O, ice is also H2O. So there is no new substance is formed. This change is called physical change of water into ice. When no new substance is formed, it's called physical change. Here, like two substance, here this new substance is formed. So it is called chemical change. Look here, difference between physical and chemical properties, physical change or chemical properties. In a physical change, you can be observed without changing the identity of the substance. No reaction take place in a physical change. And chemical change not easily observed. Change the substance into something new. A reaction take place. Okay. So in a chemical change, new substance is formed and reaction take place. And physical change, no new substance is formed, no reaction take place. Only state of matter changes, like solid to liquid, liquid to gas, gas to liquid. State of matter changes, but no new substance is formed. Okay, this is the physical properties and chemical properties. Physical properties describe the interaction between matter and energy, interaction of matter and energy. And chemical changes, new substances or species are formed. Tendency of chemical to react. Material Okay, this material, electrical, magnetic, thermal, optical, acoustic, radiological, mechanical properties. Okay, these things, and include chemical properties: stability, reactivity, toxicity, flammability. Okay, these things not related. Involve rearrangement of particles. Here involve rearrangement of particles and intermolecular forces. This thing not needed here. Only material particle involved. I'll give new definition. These things I'll cut here from. I give this. Okay, require less energy than chemical change. Here more energy is required than physical change. Observable from isolated compound, toxicated. Thus, I'll change these things. Okay, what is the definition will be physical properties and chemical properties. I explain here. This is can be observed without changing the identity of the substance. And what happened here? And by accept Midas, how many times okay, in a physical change can be observed without changing the identity of the substance. No reaction take place. Chemical change not easily observed and changes the substance into new substance, something new, and reaction take place. Okay, I'll give the physical properties and chemical properties definition or difference new things here. Okay, another thing is physical properties. Physical properties is irreversible. No, reversible. Physical properties reversible, and chemical change is sorry. Yes, physical properties reversible. If you change the energy changes previous state form. Our chemical change is not reversible; it is irreversible. So I am showing these things like a chemical change, physical change like water, ice, like ice turn into water. Turn into water is ice. Turn into water here. Ice solid particle, you know what happened. Solid ice turn into water. So here this is ice contain this the water H2O ice, and this is also H2O. Liquid water is also H2O. So no new substance is formed. This is water. Water is, if I draw the ballistic diagram of water. Water central molecule is oxygen, and here other two and central atom is oxygen, and other two atom is that. Okay, this is oxygen, and here like two hydrogen. This is hydrogen, okay, one oxygen, two hydrogen. So no new substance is formed. So this is physical properties. This is called physical properties. Physical properties. Okay, if I give heat, ice, it become if a plus heat applied, this the delta sign is heat applied, plus sign means heat. If take supply heat, solid turn become liquid. This process is called melting. And if I gain lose energy, delta minus heat released, then water become ice. So this process is reversible. Physical properties, no new substance is formed, like water, no new substance is formed, and it is reversible process. And slightly energy changes, hardly energy changes. Okay, so physical properties is reversible, and no new substance is formed. No new substances is formed. It is reversible. reversible. Okay, so this is the physical properties. Okay, now I am showing this chemical properties. Like like two substance, oxygen and okay, oxygen. Okay, air burning, air like contain oxygen. Air burning and cooking like methane gas burning. Okay, methane gas burning. Okay, new substance. When these two substance burning occur, new substance is formed. This carbon dioxide and water is formed, and also heat also formed. Okay, during the chemical properties, chemical change, new substance is formed. Energy change occur, and it is irreversible. This is the physical change. Physical change is sorry, this is the chemical change. Chemical change. So chemical change, what happened here? New substance is formed. One property, new substance is formed. New substance is formed on it is irreversible process. Irreversible process. And heat change, energy changes. Okay, new substance formed, energy changes, irreversible process. And this sign is irreversible sign, and this is a reversible sign. Okay, now look at the pages 25 to 28 at main book. (25 to 28). Samin, are you here? Tasmia, is it? Tasmia is joining. Not. Samin, take a screenshot. Are you here?
Yes, sir.
Okay, take a screenshot to discuss. Okay, this look. Have you taken a screenshot? This is the burning of a burning of a candle and 3 stages of wax. Wax is a mixture of various hydrocarbon. So what is hydrocarbon? Hydrocarbon is an organic compound made of only hydrogen and carbon are known as hydrocarbon. I am showing an example. Hydrocarbon is a organic compound. This is made by only carbon and hydrogen. Like this is a methane, this is a hydrocarbon. Here contain only carbon and only hydrogen. This is hydrocarbon. Okay, this is a sodium chloride. It is not hydrocarbon. Here is no carbon, neither hydrogen. These two elements must present. Only two elements, carbon and hydrogen. So carbon, only carbon and hydrogen containing compounds are called hydrocarbons. Like methane, if I write butane, C4H, C4H 8 no 10. This is the butane. If I write octane, octane 8 in hydrogen. This is the octane. 16, 18, octane. Okay, this is octane. These are hydrocarbon because carbon and hydrogen contain only, but it is not hydrocarbon. This is okay. So we have wax is a mixture of various hydrocarbon. I give what is wax. You write wax is a mixture of various hydrocarbon. Okay, organic compound made of hydrogen and carbon are known as hydrocarbon. In the burning of a wax, three states of matter can be observed simultaneously. There is a thin linear inside the wax. When we add fire to it, the hydrocarbon particle around the linear melt into liquid. The liquid wax absorbs heat and vaporizes first. Then the vaporized wax starts a reaction with oxygen of the air and produces carbon dioxide, water vapor, light and heat. A portion of the liquid wax remains and turns solid again. Thus, in the presence of heat, we see three states of wax. So here three states of wax we see in the presence of heat. In a wax, in the presence of heat, we find three states of matter. This is the air vaporizing occur. This is the gaseous state, and this is the liquid state. And here is the solid. When melt, this is the liquid state, and this is the solid state. Solid wax, liquid wax, and in vaporizing is. So here also two changes occur. Physical changes occur. Also chemical changes occur. So what is happening here? When the solid melt, this wax, solid wax melt from liquid wax. Here is a changes, matter changes its state. So changes, change occur, either physical change or chemical change occur. Can you say what happened when solid wax become liquid? And why? What type change occur? No, there is a state of change occur. Two type state of change occur: solid chemical change and physical change. Either it is physical change or chemical change. Liquid wax, solid burn, liquid melting ice, melting of wax, melting of wax. This is melting of wax. Can you say melting of wax, what happened? When melting occurs, no new substance is formed. So it is physical change. When this ice burning of wax occur, burning of wax start with we know burning occur reaction with oxygen. When reaction with oxygen occur of the air, produces carbon dioxide, water vapor, light and heat. So this is called burning of wax. Is called, what is type change of state? Is the physical change or chemical changes? Burning of wax, Hello student, are you listening me? Hello.
Yes, sir.
Okay, burning of wax, what type changes? And why? Huh? Physical changes or chemical changes? Either physical changes or chemical changes.
Sir, both.
Huh?
Both physical and chemical.
Burning, both are taken. Now, when burning occurs, this solid, when burning occurs, huh?
Physical change.
Burning occurs, no. When burning occurs, when vaporized wax start, a reaction take place with oxygen of the air. Air, and a reaction occur and form carbon dioxide, water vapor, light, and heat. So new substance is formed when burning occur of wax. Here chemical change occur, or when solid wax melt. So here is a two type changes occur also. Look here this melting, solid become melting, solid form, solid wax form liquid wax. This is solid wax to liquid wax. This melting is a physical change, and this burning here also occur at the top. This burning is chemical change. So here is both type changes occur, physical and chemical. Now melting, the process of transforming solid matter into liquid by means of applying heat is called melting. So melting is a process where solid turn into liquid by applying heat is called melting. At normal pressure, we know a normal pressure is standard pressure is 1 atmospheric pressure, 1 atm. What is the normal pressure? Normal pressure is 1 atm. Now we are existing 1 atm pressure, normal pressure, 1 atm pressure. At normal pressure, the temperature at which solid matter turns into liquid is called melting point of that solid. Each pure matter has its own melting point, like melting point of ice is 0 degree Celsius. So what is melting point and what is the melting? The temperature. What is melting and what is melting point?
The point, the temperature point at which solid melts down.
What is called this one? So what do you these things, similar things, one is melting, another is melting.
Melting of ice into water.
Melting is a process. Melting is a process, and in this process solid turn into process, the solid turn into liquid. Melting is a range of temperature. It is a point, temperature point, range of temperature range, or point of temperature, point of temperature, or range of temperature. Okay, it is a temperature, range of temperature, or point of temperature. Okay, melting points. The point, the temperature at which solid turn into liquid is called melting point. The process solid turn into liquid is called melting. Okay, you give the process. Here you write temperature. The temperature solid turn into liquid is called melting point. Here the process solid turn into liquid is called melting. Okay, so I'll ask you this type question in a oral viva practical test. When I take the practical class, have you seen my chemistry lab? I'll take practical class. After practical class, I'll give writing practical note. Then I'll take exam, and oral test will be taken. I'll ask question here: what is melting? What is melting point? So it is melting is a process, and melting point is the temperature. I have to finish quickly class, but long class today's. The temperature at which solid matter turns into liquid is called melting point of that solid. Okay, each substance have you join to the same link. 10 minutes remaining. So we can identify each pure solid matter has its own melting point. Like melting point of ice is 0 degrees Celsius. The process of transforming liquid matter into gas by means of heat is called, by means of heat is called boiling. At normal pressure, the temperature at which liquid turns into gas is called boiling point of that liquid. Each pure liquid matter has its own boiling point. Like boiling point of water is 100 degrees Celsius. The boiling process requires heat, but solidification removal of heat. Okay, boiling process require heat, and solidification require removal of heat. What is solidification? Boiling. Okay, this is the liquid substance. Liquid when the process is it become gas. This process is called boiling. So here heat required, heat gain, heat plus heat. You apply heat. Okay, heat apply. Is condensing occur? Condensing, freezing. It reverse process occur. If you want to do these things, condensing. If this is the boiling. If you reverse process you want to do this, is called condensing. Here need removal of heat. Here you minus heat. You minus. You remove heat. Removal of heat is required. Okay. Next things. The solidification or condensation is same. Boiling process require. No, solidification is another things. Then it is here these things. The liquid become solid. This is called solidification. Okay, this is called solidification. Particle become close. This is called solidification. It is condensing, you can say. Okay. Also freezing also. Suppose you want to find out the melting point of urea, a solid matter. Urea is a solid matter. First melting point, we need to put a net on a tripod. You put a net on a tripod. At first you take the boiling point. You want to find the boiling point, you put take tripod. Okay, at first you will take a net on the tripod. You take a net on the tripod. Net. net on a tripod. Tripod you take and put net on a tripod. Then shall place upon which you shall place at a watch glass. Then you shall watch glass here, watch glass, and there you took a urea. Put urea. It's not a urea take. Urea is white. This is what is this? You take urea, urea this, and take urea and now we shall put some urea on the watch glass and fix the thermometer linear on the stand and put the bulb of the thermometer in the urea. And here take a stand, you take a stand here, take a stand and take a thermometer and thermometer bulb. This is the bulb you put on the urea. This is the range here. Okay, this is not seen. Okay, this color, these things, reading like this, 0, 1, 2, 3, like here given range. Okay, like 0, yes, some 0, 0, 1, 2, 3, that means 10 here, 10 mark also in between. So 0 to 1 means 10 degrees Celsius, and here also some range, also here also 10 mark here. So 2 means 20. If there is a here is a 25, in the middle is the 1 and middle 5, so 15 here middle. So here is that 25, this 30, this. Okay, so this is the thermometer. Okay, bulb, you put the bulb of the thermometer in the urea. Now start giving heat on to the urea. You will find the urea will start to melt at 130 degrees Celsius. What is the melting point of urea? I'll give this MCQ question. What is melting point of urea? Then you give heat here, heat here, okay, by Bunsen burner. When temperature rise to 130 degrees Celsius, here I not properly draw thermometer. Temperature range is when 130 degrees Celsius, like here 130 degrees Celsius, it start solid urea become liquid. So the melting point of urea is 130 degrees Celsius. The temperature and all the fertilizer will melt at the same time. All the fertilizer will melt. This 130 degrees is the melting point of urea. Again, let's find out the melting point of an impure matter of, like you add some impure matter wax. In order to find it out, first we need to turn the wax into powder and collect the wax powder inside a glass tube with one side closed. Now fix the thermometer inside the following figure 2.07 and sink the glass tube in the beaker in such a way so that water can't get inside the tube. Now start heating the beaker slowly. You find the wax melting at a specific range of temperature instead of a fixed temperature. This range of temperature is the melting point of wax. Here you take wax here in this, and you find the wax melt at a range of temperature. Melting point of impure substance is lesser than that of pure substance. Okay. Okay, so melting point of a pure substance is fixed, like fixed solid ice. Pure ice melting point is 0 degrees Celsius. Sodium chloride 450 degrees Celsius. This is the fixed melting point for pure substance. If some impurity is used, melting point changes. Like melting point decreases. Okay, if impurity is used. Okay, a mixed matter will have no fixed melting point. Pure substance has fixed melting point, boiling point, but impure substance not fixed boiling point. Since all pure solid have a specific melting point, if a solid substance melt at any other temperature, the solid can be declared impure. Again, if a solid substance melt at any other temperature, not a fixed temperature, if you see the any other temperature, it means you see the solid substance is impure. We take the like I went to the pharmaceuticals medicine making company industry like Silco Pharmaceutical. I went to my training here. When the raw material come from the foreign country, they take the melting point, boiling points of the raw material to check purity. If they see the fixed melting point range is correct, so the substance is pure. So they take when raw material come from the abroad, they take the melting point, boiling point, different type tests do for finding the purity of substance. The solid can be declared impure if it melts over a range of temperature. It is impure too. For example, the melting point of sulfur at 1 atm is 115 degrees Celsius. But in an experiment, if sulfur met any other temperature or range of temperatures, the sample of sulfur can be declared adulterated or impure. Therefore, finding the melting point can be a way to find the purity of solid substance. So, melting point is the way for finding the purity of a solid substance, because solid substance melting point is necessary for solid substance, and liquid substance is boiling point of liquid. Okay, some sample of the liquid like water, the boiling point of which needs be determined, is taken in a beaker. The beaker is fixed with a thermometer. Now the beaker will be heated carefully with a Bunsen burner. At certain temperature, the water in the beaker will turn into vapor. The temperature is the boiling point of water. All the water in the beaker will vaporize at 100 degrees Celsius. That sets the boiling point of water at 100 degrees Celsius at 1 atm pressure. Since each liquid matter has a specific boiling point, why I use pressure? Because pressure is important. If pressure changes, like you take the water at water in the Mount Everest, in the peak of the Mount Everest, here pressure decreases and water start boiling at 78 degrees Celsius. So pressure is important. Normal pressure, water boiling point is 100 degrees Celsius. Since each liquid matter has a specific boiling point, so boiling point cannot be same for two liquids. If a liquid is adulterated, it will boil at different temperature, not a fixed temperature. For example, if we add some alcohol to water, it will boil at a different temperature than not 100 degrees Celsius, than 100 degrees Celsius. So boiling point can be a determiner of the purity of a liquid. So which things are required for experiment for finding boiling point? Stand, clamp, beaker, tripod, stand, net, Bunsen burner. This is the tripod stand. This is the net. Why do we use net? Net is if we give the heat directly to the beaker will break. So we use net here. And also here is a uniformly heat for give heat uniformly. So for two reasons, net is used. This is the thermometer also for finding the range of water range of temperature. So to mark now we have learned that heat is used in boiling and melting. Does not change the temperature of the matter. It only transforms the state of matter. The experiment below will tell you what will happen if we apply heat on a solid to melt. Then heat is more to boil it. Okay, now let us take some ice cube in a beaker. Heat it carefully. We shall keep watch on a attached thermometer throughout the process. Let us assume the initial temperature of the ice was now there's the experiment. Look now, see this. Okay, student, identify. Unmute. Hello student, unmute and give my question. Activity 1. Identify either physical change or chemical change. It is not property, physical change or chemical change. Identify either. Okay, I am giving some process. Melting, physical. Boiling, physical change. No new suspension is formed here. Melting of wax, no. Yeah, melting of wax, like solid wax become liquid wax, but chemicals remain same. So melting of wax is physical properties. Burning of wax, here chemical change, because here carbon dioxide from water, from heat, from energy changes. So burning of wax is okay. Freezing, like water become ice in a refrigerator. Physical change. And rusting, chemical change. Okay, like here iron in presence of water vapor and air, oxygen of air from new substance, ferric oxide, new substance form. So rusting, this jongar sileti bhashay bole rusting, this rusting is a chemical change. Experiment. Let us take some ice cube in a beaker and heat it carefully. Let us take some ice cubes in a beaker and heat it carefully. We shall keep watch on a attached thermometer throughout the process. Let us assume the initial temperature of the ice was minus 40 degrees Celsius. So you take you take beaker. You take beaker and some ice cube. Okay, some ice. This cubes ice. Okay, cube ice. Some cubic ice shape ice put here. Okay. In the beaker you take some ice. This with tamidalum. Okay, I should do some net here also. Net and you put this in a tripod. Tripod will put these things here. Tripod, and you apply this stand here. Stand, and you add a what thermometer. Okay. Okay, you will give heat here and check the range of temperature increasing properly. At the initial temperature was minus 40 degree Celsius. Okay. Or do you want to go pair? Who have want to go? The time is 12:52 p.m. Have you bath? Because the today's night is the Shabi Barat. So do you want to go? I will go. I'll finish within 10 minutes. No, 8 minutes. Okay. You want to go maybe mosque for prayer? Because okay. So I am going to finish things quickly. I'll finish. Look, this is a curve. Look at pages 29 to 30. 29. I'll read quickly. I'll try to finish this 29 to 30. Okay, look at this curve. Here's temperature is increasing. Okay, this when the temperature of the ice reaches 0 degrees Celsius, when you will apply heat. When the temperature of the ice reaches 0 degrees Celsius, absorbing the heat, they melt into liquid. Okay, this is the temperature 0 degrees Celsius. So the temperature is rising. When the 0 degrees Celsius, look at 0 degrees Celsius, it become start to melting. Water ice cubes melt into water. That proves 0 degrees Celsius as the melting point of ice. The straight line in the temperature is called melting point line. This is the straight line here. This is the straight line. This is straight line AB is called melting point line. In the figure 2.09, AB line is called melting point line. Both ice and water exist through this length. Here, both water and ice exist. Two states exist simultaneously. Both water and ice in this length, melting point line. If we apply more heat, the temperature of water start to rise. Now if this after the melting point line, if we apply heat, the temperature rises at 100 degrees Celsius. We'll see heat will not be able to raise the temperature. When it reaches 100 degrees Celsius, we will see more heat will not be able to raise. When now this temperature is not raised, there is another horizontal line, CD. Horizontal line. You see more heat. We'll see more heat will not be able to raise the temperature of water anymore. Rather than water transform into vapor. Here is a transformation occur. Water transform into vapor. Here also exists two states, liquid state and vapor is the gaseous state. All the water will vaporize at 100 at this temperature, 100 degrees Celsius. If we apply more heat, after that temperature of the water vapor will increase. Water vapor will increase. The boiling point of water is 100 degrees Celsius. CD is the line of boiling point line. This CD is the line of boiling point. Water and vapor coexist at this line. So here water state and liquid state and gaseous state exist simultaneously at the boiling point line CD. Here is the another curve. Look at it. Is the it was this one is boiling curve. Now heating curve. This one is heating curve. Here I give heat 0 to 8 giving heat. This is heating curve. This is heating curve. This heat minus 0 20 0 minus 40 20 minus 20 0. This temperature is increases because heating give heat. This curve is cooling curve. Cooling curve. At the beginning its temperature was high. When I cool temperature, it vapor become start to become liquid. This is the boiling point range. Then give fall remove heat, the liquid become to solid. This is a cooling curve. Have you seen? There is a boiling point line. This is the melting point line. Cooling curve of vapor. The graph shows the initial temperature of water vapor is 140 degree Celsius. When the process of boiling it to 100 degree Celsius, the vapor start turn into water. It remains 100 degree until all vapor is turned into water. It remains 100 degree when until the all vapor remain. When all finished, the temperature decreases. Further cooling start to decrease the temperature of water. When it reaches 0 degree Celsius, water start to transform into ice. It remains the same until all the water is turned into ice. Then the temperature of the ice decreases 0 degree Celsius. Decreases from 0 degree Celsius. The figure show decreases of temperature of ice to 0 minus of ice to minus 0 degree Celsius. This is the cooling curve. Okay, I have a question here. Okay, why this curve? Look, this curve. Okay, this question, why AB, this is the melting point line, and CD straight line is horizontal. This is the horizontal. Why? Explain it. Why AB and CD straight line is horizontal? Explain it.
It shows up the time.
Huh?
It shows up the time. The melting point of AB is like 15 seconds or 30 seconds.
Say again, what happened? This line?
This line shows us the time. How much time it will take to melt or to boil.
Here is not temperature is not rises. It remains same. It remains same. Temperature is not rises. It remains same. Why? Because here is a state changes. State here is a not temperature is not changes, because here in this line only state changes, like solid turn into liquid. state is changing. It is not raising raise temperature, because here state changing is occur. Solid turn into liquid, and also here two state simultaneously exist. Liquid, solid and liquid two exist simultaneously. Here occur transformation of state occur. In this AB line, state transformation occur, like solid to liquid. When all solid turn into liquid, then temperature increases until they remain same, because here transformation of state occur. And also during these things, energy supplied is used. When we used energy, heat applied, this supplied energy is used for breaking bond between the molecules and particles. This heat applied energy is used for breaking bond the molecules, and the particles don't absorb energy. So here is energy is used for breaking bond. So particle don't absorb energy during this transformation energy, but this energy is used for breaking bond. Okay, so here new bond is formed, but state of substances remains same. For these reasons, this line remain horizontal. Okay, now next as given assignment, everything will be clear. Okay, interconversion between the three states of matter. This solid state, when we energy put in, solid turn into melting by a process. Solid turn into liquid by a process is called melting. When energy taken out, liquid turn into solid. This process is called freezing. Okay, when energy put in a liquid, liquid turn into energy give liquid turn into gas is called boiling. This process is boiling. When energy taken out, gas turn into liquid is called condensing. And when solid turn directly to gas, like naphthalene directly turn into gas, we find an aspect throughout the room. The naphthalene directly turn into solid. This process is called sublimation. And gas turn directly to solid, this process is called deposition. And solid turn directly to gas without being liquid, this process is called sublimation. Now look at page 31. The process of heating a liquid and turning into gas is called evaporation or vaporization. When water from hot tea is converted to vapor, that is an example of vaporization. Again, if we cool that vapor, the vapor turns into liquid. This process is called condensation. For example, water vapor emits heat and turns into water, which is condensation. The process of heating a liquid into a vapor and retrieving the liquid from the vapor by cooling, it is called distillation. That means distillation is vaporization plus condensation. Okay, the process in which heating a solid directly turn in the liquid solid state into a gaseous substance instead of a liquid is called sublimation. Ammonium chloride is NH4Cl. I'll give the in a exam Write the which one is the formula of, correct formula of ammonium chloride. Ammonium chloride is NH4Cl. Camphor C6H16O. Naphthalene formula is C10H8. Solid carbon dioxide, iodine I2. Ammonium chloride are the matter that don't turn liquid if we heat is applied. Instead they vaporize. These substances are called sublimated substance. Okay, this substance, ammonium chloride, camphor, naphthalene, solid carbon dioxide, iodine, aluminum chloride, they don't turn into liquid. Instead of being liquid, they turn directly gas. These substances are called sublimated substance. I will give some example. Which one is sublimated substance? Here, solid turn into directly gas in a sublimation substance. If we sublimated substance is mixed with some solid matter, it can. Okay, student, thank you for joining today's class. I will explain these things class. I'll take a class, another extra class I will take. Okay, then I'll take exam. Thank you. Today we will not finish this thing.